Alrighty. Since when we went over binary search in class and we're talking about arrays, there still seemed to be some confusion about how they work, how to build one or access it. I'm just going to revisit arrays. We had some earlier description in our notes from when we're talking about data types, but it's been a while since then, so I think it's worth going back over it for a bit. So up here at the top, we have a diagram effectively of an arbitrary array of integers as kind of expressed in code as if it's Java, but a lot of languages use a similar syntax. And then sort of a conceptual layout of what an array looks like, as well as kind of how this maps to memory. And you don't have to worry about any of this. It's mostly for the purposes of, for the rest of the discussion and talking about how arrays are conceptualized and work. If you're thinking to yourself, well, what does that really do? Or what does that really mean? Or why do we do something? The deeper technical discussion, can help inform that and will hopefully make it make sense, such that when you're thinking about them and working with them, you know why things are done the way they are and kind of what's going on in terms of memory. So just to begin, an array is a contiguous chunk of memory that has a number of elements, right? So each one of these things is an element that is of some other kind of data type. And each of them is going to be exactly the same kind of data type. You can't mix in different kinds of data in a single array. And the reason for that is when we're looking at the whole array in memory, the way that the computer figures out how to get each piece of information that is stored in the array, it uses its index as a multiplier to an offset, right? So the very beginning of the array, index 0, has some memory address, whatever it is. In this example, I'm just using all zeros because it's easier to represent it that way rather than starting at some other number. It's just easier to see the difference. So if the very beginning of the array is at memory address 0, then at this point we have the first element stored, right? So the value 16 stored in hexadecimal just looks like 10, right? So if you remember your conversion from decimal to hexadecimal, that's 10 in hexadecimal is the value 16. So if we want to access element number 1, or the second element at index number 1, the computer then takes the initial memory address for the array and then multiplies 1 times however big each of these things are, right? So for an integer in Java, that's 32 bits or 4 bytes. So every time, we're always going to use that exact same multiplier, or that same value. So we're going to take 1 and we're going to multiply that by 4. So there's 4 bytes that we're then going to add onto the initial memory address, right? So we started at all zeros, and when we add 4 bytes, we're now at address 4, and this is where the second element is stored. So all zeros and then a C is 12. And if we wanted number, the third element, or index 2, we're going to do the same thing. We're just going to multiply 2 times 4 to get 8, add that to our starting memory address, and then we get to where the next one is. And it just keeps doing this for however many elements are in the array. Now you'll notice, so this is a really simple example. It just has 4 elements. But if we were to try and access index number 4, it would actually be out here. It would be past the end of the array, and there isn't anything there relative to the array. In memory, there would be something here. It's probably some other variable, or it might not be allocated to anything. It's possible that there's just an unused space that exists in memory that's right here. So there's effectively junk in memory. So if you went to look at what that junk was and you treated it like it was part of your array, then it would just take these bytes, whatever they were, try to interpret them as an integer, and then give that back to you, which, if there's just random junk in here, the value might not make any sense. So that's why tools, systems like Java, where there's a lot of stuff that goes on invisibly to you, will do things like, if your program attempts to access an index which is not valid, so something that is less than 0 or more than the highest index, which is going to be the number of elements in the array minus 1, then it's going to throw an exception, which is called an array out of bounds exception. And I'll demonstrate some of this in a minute, just so you can see it at play, so that when you're working on your assignment, if you run into this kind of stuff, you'll know what's going on, and it hopefully won't be as frustrating. So anyway, so this is your conceptual view of the array, but now let's kind of look at it in code. Like, if we were going to try to create this thing, how do we do it? What would it look like? So I just created a new project in BlueJ, CITC, which that's right, 1301, and we just have our initial class that we've created. I also called it CITC 1301, and I went ahead and modified the default just a little bit. I removed the member, that X that used to be here, and I moved some of the braces around. So if you'll notice that the curly braces were initially below the signature, and that's not necessary. They can be on the same line. I kind of like this opening up here and then closing down here. I just think it looks a little cleaner for me, but that's totally your preference. It's whatever you think makes your code more readable. So if we want to, let's say, create one that would exist for, let's see, let's just go ahead and say that, oh, well, here we have our index up here. So this would normally be for an instance of this class, right? We're going to do this statically, just like we talked about in class, so that this variable, and we'll call it list, so that it's more reflective of kind of conceptually what we're talking about. And the syntax, so just int by itself would be giving it a type of an integer, but when we put the brackets after that, then that's the syntax for an array. So this is going to create a private, which just means that other classes, other code in your program, if you had more than one, wouldn't be able to access this member directly. So if you tried to access, and the syntax on that, just to give you an idea, would be, if you had CITC 1301, which is the name of our class, dot list, which, so dot is to access a member of something. So attributes or fields, like list, are members, and then also the methods that you've associated with the class are also members. So either one of those are accessed in the same way. It's just the name of the thing, a dot, and then the name of the member that you're trying to access. So because this is static, we talk about the class and not an instance of the class. And I realize that's kind of confusing right now, and don't worry too much about the difference. It would just be that if we wanted to talk about this thing, that's how we would do it. But because it's private, we can only do it inside of this class. So only the code that we write somewhere in here is going to be able to access this thing in that way. However, because it is local to our class, we don't have to use that full syntax. Instead, we can just call it list. And any place that we call list in our code is going to use this one. So now, currently, we've just created a variable that will store an integer array. That's it, right? It's not been allocated any memory yet. So it doesn't really exist anywhere, except we now have defined what the name is and what kind of data is going to be associated with it. But it doesn't live anywhere yet. We can't actually call it. We can't do anything with it. If we tried to call this, because there's nothing, it would just be, what's called null. There's a different term in different languages, but it would be null. There's no data there, so you wouldn't be able to do anything with it. So before we can do something with it, we have to make a new one. So new is our syntax for creating a new object in Java. You don't have to, again, worry too much about what objects really are. They're different from our primitives. If you remember from several weeks back when we talked about data types, an integer is a primitive. So it can't be broken down into anything smaller, and you can just use it all by itself. So just like the initial example that was here, right, if we said private int x equals 1, it just stores an integer, and we just stuff a value into it. We don't have to make a new one. To, I guess, potentially confuse matters a little bit more, but just to be clear in the explanation. So in our conceptual index up here, we have foo as our variable name, right, rather than list. So here it's list, and here it's foo. So just saying foo, or in this case list, what's really stored in the memory address is the address to the array, right? So if we're just talking about an integer, well, it's the address to the integer. But so instead of having like 4 boxes, there would just be 1 box, and that's all there is. But it already has the memory. It already has a memory address. But because this is really a special kind of object, it isn't quite a primitive, Java doesn't assign it any memory until we make a new one. It gives us a couple, properties that become useful later as we work with more complex code. But for right now, just be aware of the fact that we have to create a brand new one before we can actually put information into it. And when we're creating a new one, we have to tell Java how big we want to make it. So if we're going to replicate this array that we have up here, then it's going to have exactly 4 elements in it. And there's a shortcut for how you can specify the contents of a brand new array without having to write yet more a bunch of code. But we'll do it both ways, just so you can see the difference and why this is a shortcut and not the only way that it's ever possible to do it. So the shortcut are curly braces with each of the elements inside of it separated by commas. So because we're just working with integers, we can just type them out. If we had something more complex, it wouldn't necessarily be something that we could create on the spot. If so, just ignore that. We're dealing with integers, so we can just type in those values. So we have 16, 12, 67, and 89. And you can follow along and do some of this stuff in BlueJ just to get a little more familiar with writing code and compiling it and trying some stuff out. And then we finish off with a semicolon because that's how we end any of our statements in Java. So now this has, and when we compile this, whoops, what did I not do? Equals new int array. What did I do? Trying to think. Ha. Okay. My bad. In this particular case, okay, so there'd be two ways here. So I get rusty too. So anyhow, we have our new integer array, and because we're using this shortcut to go ahead and tell Java what all of the elements are in the array at the very moment that we create it, it's able to take advantage of this, and it knows already what that number would be. So in this case, the compiler was confused, or it found a discrepancy in that I was trying to tell it how big it was, and then part of this usage, part of the syntax, is also trying to tell it how big it was, and it said, wait, you've already done that and you've confused me. So we don't actually need to put a value in here if we're using the syntax. However, just to show the other way, private int array, and we'll just call it list number 2 equals new int, and then here we're just going to give it how big it would be. And when we go to compile, now we don't have any problems. So this one, so in both cases, this array and this array are both allocated the same amount of memory, right? They each have 4 integers. The only difference is this one is already populated with values. So the relative chunk of memory already has our values 16, 12, 67, and 89 stored in those memory locations, whereas this one is empty. Or rather, very likely there's just junk in there. But Java knows that we haven't assigned any values. So until we do that, the way it handles it is all of these are treated as 0. Right? So while it's empty, if we said, let's come down here, and we're just going to change our sample method. We'll take out our parameter just so we don't have to mess with it right now. And another thing I'm going to change, and you don't have to worry a lot about this right now, but the special keyword void just means that this, I got to make this static. I have to make this static to talk about anything else that is also static. So now what I've done is I've made it so that this method no longer needs to return anything. So now this return statement isn't actually valid. Because in Java you don't always need to give back a value. Sometimes you change the properties of an object and that's all you did. And you might not need to get a value back when you did it. And just for the purposes of playing with arrays, that's all we really need to do at the moment. So because our list is static, we can always talk about it. So if I said system.out println and I say list1, and so to access any given element of the array, and I'm going to add a little space in here just so it's a bit easier for you to see what's inside the parenthesis. So system out print line. System is a special built-in. Out is a member of system, and then print line, println, is a member of out. So you don't have to worry too much about the details, but what this is going to do is print out the value that that we give it to the console, and so we'll just be able to visibly see the results of running this method. And then so that we can see the difference, we're going to access the same member, right, the first element of the second array, which doesn't have anything in it yet. We're going to compile that. Whoops. Oh, I forgot my semicolons. So yeah, BlueJ will help you out, and it tries to point out where things are wrong. Sometimes it's more helpful than other times, but so now when we compile, whoops, cannot find symbol variable list1. Oh, that's right, because I just call it list, not list1. So that's again, everybody gets rusty here. So if you see things like that, it's just because you didn't use the same variable name, and it could just be that you typed it over, or you temporarily forgot what you had called it, just like I did, and that's okay. So now everything compiles, which means it could find these variables and it knows what we're talking about. So we come over here to our class, and because our sample is static, we can just call it without creating anything. And when we do that, so we got 16, which was the value that we stored in the first element of this array, and this other one, which didn't have any values put into it, just gives us 0. So if we wanted to put our values into here, then we would need some additional code to do that. So in your assignment, you're not going to need to make any alterations to your list. But the syntax that we're using to access any member of the array is exactly the same. So, but if we wanted to say list2 0, so that we're talking about the again, very first element of the array, and when we're talking out statements in Java or a whole bunch of languages, when we make an assignment, this is usually just called gets. So if you think about it, this variable, right? So the very first chunk of this array, very first element slot, index, is going to be given the value, assigned the value that is on the right-hand side of the equals mark. So in this case, if we just put the same value in there, then list2 index 0 gets 16. So we're just putting 16 into that memory location, into that variable. So we compile it. It's totally cool because we gave it an integer and we're storing integers in our list. If we had given it something else, so just to show you what will happen, if I give it 16.0, even though we might think of that as exactly the same thing, this is actually a literal for a real number, right? So it's something that's talking about more or less, infinite precision. It's not just the flat number 16. So in this case, we're talking about 16 and nothing else. So it's actually a different kind of value. So if we try to stuff this into our list of integers, it isn't going to work because they're not the same data type. Now by default, this guy's going to be called a double, if you remember that from when we talked about data types. And it is actually the same number of bytes to store a double and to store an int. But because they're not exactly the same type, Java has issues with that. And that may sound like it makes programming in Java more difficult, but at the same time, it's going to help make your code easier to write and work better because you're not having to worry at any moment in time as to whether or not this value happened to be an integer or it happened to be a real number, or it's even possible that it happened to be a string that contained the characters that would have represented a number, right? So if we have the string 16, okay, well, we read that and we see that that's representing the value of 16, but it's a textual representation. It isn't a number. So if we try to compile it, it's going to tell us that Java-lang string, this is actually a kind of object, just like our array is a kind of object. It's not a primitive, even though we work with them a whole lot. They're not primitives. So it's not able to put that data in there. They're just not compatible. So anyway, so if we put 16 into the first element, index of the array, and we run this line of code again, now, whoops, okay. I just instantiated one of these. It's not really going to do me any good. That was just this default up here is called a constructor. So if I were going to build an instance of this class, it wouldn't have any special members to it except this X. That's the only thing that would live inside of here, but it's not able to do anything, so that's fine. We don't have to worry about it right now. So now we see that we get 16 from list, which we initialized up here and already had 16 in it, but now the first time that we called it list2 index 0 didn't have any information in it, so it just gave us 0, but after we've assigned something to it and we access it again, the 16 is in there. And just to kind of demonstrate using it on the other side of the gets, just for a moment, let's say that list1 gets list2 index 0. So basically what this is going to do is it's going to look in list2, the first element, index 0, and take whatever value is inside there, and it's going to store exactly that same value into the second element, or index 1, of the same array. So it's just moving that data. It's not, well, it doesn't take it away from where it was originally. It's just going to use that same value and put another copy of that same value into the other element of the array. So now we're going to have two 16s. So it'll go 16, 16, 0, 0. All right. So for your assignment, you're not doing straight up iteration over an array, but I'm going to demonstrate what that looks like a little bit, just so again we're getting more familiarity with how we work with arrays. So we're going to say while I'll have to make another variable if I care about that. It's okay. So what we're going to do is we're just going to turn this guy static just so we can talk about it. And yeah, we'll just leave it as X. It's fine. It doesn't really have any special meaning. We're just going to use X to help control our while loop. Yeah. Okay. So we're going to say while x is less than, and we're going to iterate over our first list. So that was just the variable name of list, and then something that is provided by Java as a built-in member that is publicly accessible. So remember that I talked earlier about how this list is private to our class CITC 1301. So this special, this member of the class called array is actually made public so that you can call it from anywhere, because this is part of a built-in, and Java wants to make it easy to use, and if we didn't make it publicly accessible, you wouldn't be able to just get to it. So the whole point here is that we can find out at any point in time whether we created this list inside of our code or whether or not it came from somewhere else, like another system. We can find out exactly how big this thing is, right? So list.length will always contain the number of elements in that list. Now that doesn't mean how many values have been filled into that list. In fact, we'll just demonstrate that real quick. So we've already kind of seen us printing out some of the values that are inside of it. I don't think we care as much right now about seeing those again. Well, let me do, okay, I'll leave that one. I'm going to take out this other print command, but I'm leaving in the two statements that are actually assigning values to our second list, just so we can see something in there and see the difference. But I'm going to take out these other printing statements, just so that we're seeing less, get printed out. And I'll just make some space. It's not really convention, but I'm just making it a little bit easier to see what I'm putting inside of the parenthesis, because there's only so much screen real estate here. But we're just going to put in list, whoops, if I type it correctly, list.length. So that's going to tell us how many things are in the first one. And then list2.length. And alright, so all I'm doing that for real super quick, if we remember from our for loops where at the very end we would have like I++ to automatically increment x by 1, our variable by one number, I'm just preventing this while loop from running on forever. So it isn't going to actually do any work other than changing x, which we won't actually see the results of.